Our next speaker is Dr. Lapenna Antonio Gerardo. Dr. Lapenna is an AI instructor at the Volta Institute. He holds 2 degrees from the Lewis University in Rome. At the Volta Institute, he teaches professionals across various sectors about what artificial intelligence is and best practices of artificial intelligence, guiding them on how to apply AI effectively to improve their work and decision making process. In addition to his academic activity, he is a tech entrepreneur helping organizations and professionals implement AI in real tech wall settings. At just 25 years old, he is deeply committed to advancing AI research, spreading knowledge, and contributing to the development of next generation of artificial intelligence systems. Please join me in welcoming our keynote speaker, Dr. Lapenna.
Thank you very much for introducing me, Kiran. And right now I will share my screen to talk about what the future of intelligence is. So what the future of artificial intelligence is. There is one of the most important things because we have spoke about what the future of the economy is, of the industries is, which will be empowered by artificial intelligence. And that is good because the future of economy will be empowered by artificial intelligence. This is 100% true. But right now we have to talk about what the future of the future. But right now we have to talk about not only what the future of of industries is, but what the future of artificial intelligence itself is. And we will dive into the technicalities and the technical aspect of AI. Let me share my screen so I can talk about that. Thank you very much for introducing me. And all right, here we go. So the future of artificial intelligence, when artificial neural network meet living brain cell, because we have spoke about artificial neural network, but what artificial neural networks are? Artificial neural network are the emulation and simulation of a biological neural network, which is one of the most important things in order to describe intelligence. And this is something that talks about the future of AI when artificial neural network meet living brain cell. So artificial neural network in their architectures have 3 different kind of layers. The input layer, when they take, for instance, the written text or the images, when we're talking about convolutional neural network. Then they have the hidden layer, where there is the processing and the reasoning itself. And then there is the output layer, when there is the result. When there is the result, of something, of some reasoning. And this is the mimic of intelligence, because we are talking about what intelligence is and what artificial intelligence is. So we right now know that a machine can be intelligent. A machine can be intelligent artificially. So with Geoffrey Hinton, there is considered the godfather of AI. In 1986, has discovered artificial neural network, and then in 2006, deep learning neural network with more set of hidden layers. He has said that a machine can think, and there is the Turing test with which we know that a machine can think, because the Turing test is going to evaluate the intelligence of a machine by making humans believe that also the machine is human. So these are the artificial neural networks, which are going to represent the most concrete thing to have artificial synapses, which is similar to the biological synapses, wherein human intelligence or animal intelligence happens. So let's see about the biological neural system. So the biological neural system is something that we have, which is going to inspire the artificial neural system. That is very important because it is going to be inspired, the artificial neural system, by the biological neural system, since scientists have said to each other, all right, we have to make a machine intelligence. So they have happily said, in order to make a machine intelligent, we need to emulate what is going to be the human brain. So they have emulated the human brain, and there is this simulation with artificial neural networks. So this was a brand new innovation in the 80s that has given form of a new kind of intelligence that is artificial. So that is why it was extremely innovative and still is to these days extremely innovative. But this is still the concept of weak AI. Today I want to talk, and I will talk about the future of AI. How? By introducing what is the biodigital integration. So there is the convergence point where silicon meets living cells. Let me explain myself better. A couple of months ago, it was released the first form of synthetic biological intelligence with biological components unifying, so living brain cells unifying with mother cards of an hardware. This is one of the most innovative factors with the living brain cells, which were unifying with the mother card of an hardware by making happen a reasoning that is synthetic. It's not only biological, it's not only artificial, but it's the union between biological component and artificial neural network, which is something in a positive way crazy, because it's not like 15 years ago when scientists were thinking about the hypothesis of having a machine that thinks, because this is true, a machine can think. It's not like, all right, humans can think, yeah, there is a biological intelligence and there is also an artificial intelligence. It's the union between artificial intelligence and the biological intelligence with the biodigital integrations. That is why I've said when I was introducing this work that I will talk about the future of intelligence, not only the future of economies and industries due to positive externalities from artificial intelligence, but the future of intelligence itself, which is not only biological, because there won't be only human working on things. There is not only artificial, because there won't be only machines working on things, but it will be synthetic, with a synthetic biological intelligence and a biodigital integration. Indeed, the first computer which was released, it was the CL1. There is the computer when silicon meet neurons. So where the biological synapses, living brain cells were in the computer. This is crazy. This is crazy, and this is also enthusiastically crazy, because we are thinking about intelligence. We can think about a human mind or an artificial intelligence. Right now, we can paradoxically think out a biological components which meets artificial components. So, and then we will also see the future of intelligence. As I said, there is a synthetic union between biological and artificial system. This is one of the most important things. Now, I will move on beyond the digital intelligence, because most of you guys can say that artificial intelligence is the last invention of mankind. And this may be true, because the next inventions will be done with the help of artificial intelligence. And personally, if I ever invent something, if I ever make something, it will be done with the help of artificial intelligence, because I live with artificial intelligence. I have AI agents that work for me, and I help people by implementing their AI agents. I help professionals across various sectors and also companies and organizations for this, and I offer those services in an efficient way. And I already live with artificial intelligence. So according to my personal experience, I deeply believe that artificial intelligence is the last invention of mankind. But we are going to go beyond digital intelligence. We are going to go beyond what a digital intelligence is. And artificial intelligence indeed is evolving past traditional computation. And we are entering right here and right now in an era of SBE. There is a synthetic biological intelligence. It's a union between artificial components and biological components, where digital algorithms are going to meet biological neurons and interact directly with them. And this convergence is not just a metaphor. it's an engineering reality, because whoever is working on emerging technologies knows that this is an engineering reality. And let's see the traditional AI, which is based on algorithms and digital processing, which is similar to the AI that we have nowadays with general artificial intelligence. Then we will have the synthetic biological intelligence. As I said, there is a union between digital algorithms and biological neurons, and this is an engineering reality, because with computer CL1, it's happening right here and right now. But before understanding what are the positive aspects among a synthetic biological intelligence, which is the union between artificial components and biological components, we need to understand what is a biological neural network, because there will be a much less consume in terms of power from biological neural networks, since the human brain contains approximately around 90 billions, here it says 86 billions of neurons, and around 100 trillion synaptic connection, which are enabling real-time perception in the terms of processing information, of decisions making, and so on. So 86 billion neurons in the human brain. This is crazy. And 100 trillion synaptic connections. And this will enable the complex processing. But the magic, the miracle of human brain, it happens now that we do not consume that much. We need to eat, we need to go to the bathroom, we need to sleep, we need all of those things. But in terms of power consumptions, we just need 20 watts, right? So we just need 20 watts, and there is a remarkable efficient processing. And in terms of sustainability, this is important, all right? Because we just need 20 watts, guys. What's going on? Our brain is amazing, because we need 20 watts in terms of processing. Everything is going on around our neurons and around our synaptic connections. So we will see the artificial neural networks, the capabilities and its limitation. I have already introduced the artificial neural networks with an input layer, with hidden layer, and with output layer. So artificial neural networks, and we have to see its capabilities, what they can do, and their limitations. So artificial neural networks are structured in layered topologies, which can be feed-forward, convolutional, or recurrent. For instance, the convolutional neural network, as the doctor which spoke before me have said, with the practice of max pooling, they have to analyze the images, and those have an applicability in medicine, which is huge, because convolutional neural network can analyze images in radiology. There is something in a positive way crazy. And basically, what is going on here with artificial neural networks? They have a lot of capabilities, such as the convolutional neural networks, which can literally see. So they have a vision, machines who have a vision. And as I said, in the medicine world, there is a huge applicability, because they can see radiology and they can analyze, as the doctor previously said, they can analyze images in real time, even better than human. So they have layered topologies, which can be feed-forward, convolutional, recent structures, forming architectural foundation of what is the modern artificial intelligence, because the modern AI talks about artificial neural network, which are going to make an artificial synapses. Then we have learning mechanisms. So this is good, because we have learning mechanism, and they have gradient descent and backpropagation algorithms. So what is backpropagation? Backpropagation is the system which allows a neural network to learn by its own. And this is huge, because the concept of backpropagation was introduced by the godfather of artificial intelligence, which is Geoffrey Hinton. So learning mechanism, it's one of the positive aspects. It's one of the capabilities of artificial neural network. Now we'll talk about the main limitations, like the energy demand, because obviously AI is applied in the whole world, so it costs a lot in terms of data center and energy demand of servers which have to sustain artificial intelligence. So there is a high power consumption during the training and interference phases, which is going to require significant computational resources. This is an important aspect. It's going to require significant computational resources, which are very, very important. And then we have data requirements, which are intensive data, the needs for an effective learning, as the slide says. And the point is that they need to achieve accuracy. And in order to achieve accuracy, they are going to need millions of examples. So that is why the energy demands will increase, because in an algorithm, we have the training phase, then we have the test phase. And in the training phase, we need to train an algorithm, and we need the energy in order to train these algorithms, all right? So we're gonna have synapses, comparisons, here with biological versus artificial. So before unifying biological synapses with biological components with artificial components, we are going to see their comparison. So we are going to see the positive aspects of those components and the negative aspects of those components. So biological synapses adjust transmission probability through a practice which is called ion channel regulation, which have mechanisms like LTP, which is the long-term potentiation, and the long-term depression, there is LTD. So here there is the biological synapses. And there is a neurotransmitter release. There is, according to neuroscientists and engineers in the whole world and in this sector, there is something incredible. It is something incredible because it is something that it allows people to process information without the much bad consumption. Then we're gonna have artificial synapses, which is the scalar weight in matrices and mathematical operations. And the artificial synapses, as I said, with an input layer, with hidden layers, and with output layer, they have this predetermined architecture. So they have an amazing and extraordinary computational capacity, but they consume a lot. That is why there is the emergence from an engineering perspective of integrated system which are adaptive hardware with neuromorphic computing. There is important with an hybrid learning mechanism. So with biological components such as living brain cells and mother card, which is an hardware. And this is a dynamic reconfiguration. So what is synthetic biological intelligence? Synthetic biological intelligence, it is something that is going to unify biological components and artificial components, and it involves in closed loop feedback. And those are closed loop feedback because are going to be feedback also in a way, we could say, of the testing phase of the algorithm logic that we are going to check between real neurons and computational interface. And this is not wholly biomimicry, but this is biology. This is biology in the loop, in a computer science loop. So this is a union between computer science and biology, and it offers continuous learning by consuming less, because one of the most innovative factors in terms of a synthetic biological intelligence, which is an intelligence that has artificial components and also has biological components, it is going to be a biophysical efficiency, because there are also physical limitations in terms of the step that a machine has to take in order to think. There are biophysical limitations and physical limitations from a physical perspective, but with this biophysical efficiency of biological computers, which were released just a couple of months ago, we have an efficiency which brings not only artificial intelligence, which brings intelligence to the next level. This is one of the most important things because it tests real neurons, real living brain cells. This is crazy. Real living brain cells and computational interfaces with digital systems for input and output, which are two of the most impressive component in neural networks, which could be artificial neural networks or biological neural networks. As we said, they have a closed loop feedback because they have a continuous adapting cycle. And another important thing is that this is an emergent intelligence. This is a new form of intelligence, which is not only human, which is not only artificial, but this synthetic is the union between biological components and artificial components. And this is an engineering reality. It's not just a science fiction as it could have been a decade or a couple of decades ago. It's something which is real because there is Dish Brain and CL1, which is the first biological computer that was released from a startup in Melbourne in Australia a couple of months ago. So it was created by Critical Labs and is going to use 800,000, almost a million of human neurons, which have grown in a multi-electrode array that is called MEA, that was trained by electrical simulation, and neurons have learned in this specific example to play in a simulated Pong environment. So this was enthusiastic, and this has led CL1, the first biological computer, to have a modular neurosilicon device where every chip of that biological computer is a so-called bioprocessor. There is something completely new, such as this concept of synthetic biological intelligence. It is something extremely new. There is going to analyze the future of intelligence itself. There was the Pong training, so with the neurons who have learned to play simultaneously via Pong feedback. And then the CL1 creation, as I said, the modular neurosilicon device bioprocessor, and the digital integration, the real-time neural computation in a digital workflow. So CL1 architecture and operation. Let's dig into this first biological computer, which I encourage you guys to go and take a look at this first biological computer because it's something amazing. So if you see a picture, just look out up in the internet. If you see a picture of this hardware, of this biological computer, you are going to see the living brain cells in this hardware, similarly to this image, which was made obviously by AI, by the power of generative adversarial network that artificial intelligence has. So the CL1 architecture is the following. Has acculturated neurons on the MEA interface with a so-called FBGA logic. So there is a kind of training which is a spike training. There is no a training like simple artificial neural network, but it is a training that is going to encode stimuli inputs. And this is going to make it possible what is so-called from neuroscientists, because in this field, there are involved not only as a teacher, as instructor, as professor, as engineers, as researchers, as computer scientists, not only has are involved in this field, but also neuroscientists. Also neuroscientists, because we are literally talking about a new form of intelligence. There is no biological, it's not artificial, it's synthetic. It's a union between biological and artificial intelligence by taking into account the positive aspects of biological efficiency and the positive aspects of artificial processing, which is huge. So neural response captured via electrocodes and analyzed by machine learning, which, as you all know, is a subset of artificial intelligence. Then we're gonna have a continuous closed loop feedback reinforcement. What it does mean. So basically, A continuous closed-loop feedback reinforcement, it means basically that in an unsupervised way, this synthetic biological intelligence can learn in an efficient way and can literally behave. So it's going to form a behavior because it's going to have perceptions, it's going to feel emotions, which is something that as a humans we all do. There is who feel stronger emotions and who doesn't, but basically we all feel that. And this is going to feel a real behavior, this form of synthetic biological intelligence, and it is the next phase of AI. Now we will see one crazy graph. So this crazy graph basically shows us how human brain is efficient. It is extremely efficient because here we see that human brains is going to use only 20 watt for performing scales operations. Meanwhile, GPT-3, which is amazing, but GPT-3 per hour, he's going to use around 1,000 more or even 10,000 more the energy that the biological components allow the CL1 rack, which has 30 chips to run. Because here in this graph, we have the human brain, as I said, only 20 watt, all right? Then we have the CL1, which has a power consumption of 1,000 watt. And maybe a big why? Because the CL1 is the first form of synthetic biological intelligence. There is the union between artificial intelligence and biological components. Then we have GPT-3, which is only artificial intelligence, which has roughly 1,470,000 of watt in terms of power consumptions. So that is why synthetic biological intelligence is the future of intelligence, and it is the future of humanity in a way, because when you can have an intelligence which is going to consume less, everybody is going to be interested in it. Because one of the biggest problems, one of the biggest barriers in terms of entry in those kind of markets is also the power consumptions. But if you use human brain living cells, it has been demonstrated by scientists, and this is going on right now, that there is going to be much more efficiency. So why efficiency matters? It matters, as we all know, to have a climate responsible computing, because obviously if it consumes a lot of watts, there is going to be a problem. There is going to be a problem in terms of climate, because it's going to waste a lot of energy. I am a scientist. I don't care about left, right, and so on. I came up only with scientific conclusion, all right? So if it's a scientific truth that we can protect the climate with this new form of intelligence, there is also more efficient to process information with synthetic biological intelligence. This makes me think that it's one hint more for which it can be the future. So there are also edge AI applications which have a local processing without a so-called cloud dependencies. I would love to go into every details of cloud dependencies and so on, but I should speak for 10 hours, and I really hope that you're enjoying this, because it's something which is going to talk about not only the future of economies with AI, but the future of intelligence itself. There is not only human, not only artificial, but synthetic. And also in terms of robotic and neuroprosthetic, there is a system which is going to be much more efficient with the synthetic biological intelligence rather than with AI, and is going to overcome what we know as physical limitations like latency constraints and so on that we have with hardware that we have nowadays. That is why with the biological computer, with quantum computing, the concept of intelligence itself will grow even more. So this is just the beginning. This is just the beginning of AI, which in my opinion is overestimated in the short term, but is underestimated in the long term, because we will need AI. That's the truth. Like in anything that we do, we are going to need AI. I am going to live with AI, for God's willing, always, every day. That's it. So that is why in the future will always be exponentially more important. We are going to see synaptic plasticity and real-time learning with the neurons that are continuously going to modify their synaptic way with a practice that is called calcium-driven cadences and receptor redistribution. And in a synthetic biological intelligence systems, those are going to translate in a new way of learning. So a real-time learning in an unsupervised way with pre-programmed way and fixed datasets. So one of the most important things here is not only the real-time learning, but is why there is this real-time learning. And the most important component of why there is this real-time learning is the receptor redistribution. So physical changes in a synapses with these receptors that are going to physically, because we are also talking about physics and neuroscience. We are not just talking about computer science, we are talking about physics and neuroscience. And with the union of those, we can have a synthetic biological intelligence with this synaptic plasticity, which is going to form a new behavior, which can compute more, also because it's more efficient. And we will introduce also a concept which is important here of the spiking neural networks. So we spoke about the biological neural networks, the artificial neural networks, but we can talk about something which is even more efficient to form a new form of intelligence. There is the synthetic biological intelligence, and those are the spiking neural networks, because the spiking neural networks are going to process information through a discrete spikes, and they have an amazing encoding which is going to use a spike timing dependent plasticity, which I encourage all of you to look at, because thanks to this spike timing dependent plasticity, what we have is a spike generation. So those are neurons which are going to fire a discrete action potentials when a membrane in our brain it exceed their threshold, because we also have limits. I myself have many limits, but thanks to this spike generation of these spiking neural networks, we can prevent those and we can move forward always more with this new concept of SBA, synthetic biological intelligence, which also has a temporal encoding where the information is encoded in the timing and in a new kind of pattern, and it does not have any more continuous values, because it will be and it is like a real behavior, because the biological computers are already in the market, and their price is estimated to be around 30K, something like that. They are already in the market, and they have a STDP learning. So synaptic weights will adjust how? By basing themselves on a relative time pre and after the spikes that we have spoke about here. So the spiking synapses. Then we're going to have the hybrid integration, where biological neurons and artificial spiking neural networks will combine together for having an aware cognition which will form a new kind of behavior. So we have spoke about the artificial synapses, which is going to use mathematical operations and optimize for specific tasks. The biological synapses, which is energy efficient. And now we have to have hybrid results, which is the future of intelligence and the future of humanity itself, with the lower energy consumptions. That is crucial, and it is adaptive. It's adaptive to novel, to complete brand new situations. Now, we go into a point that I really like. So, which is one question. Honestly, I do not know the answer. I don't think there is possible to have an artificial consciousness because I personally think the Holy God can create consciousness, but artificial consciousness is something which is the second step for many scientists, for many neuroscientists, for many engineers after artificial intelligence. Because we all know that a machine can be intelligent, but do we know if a machine can be conscious? As I said, one of the greatest in AI, which is Geoffrey Hinton, the godfather of AI, has said something about it, and many scientists also have said, and the way they were talking, it made me think that for them, there is the possibility of a machine being conscious. And in my personal view, there is a strong possibility of we all being, kind of believing that a machine seems conscious, because already the Turing test, which was overcome by GPT 4.5 with 73% of accuracy, as one specific goal, so making us believe that a machine is human. So the perception of artificial consciousness for me is possible. Artificial consciousness itself for me is not possible. But what scientists, neuroscientists, and engineers says, they think that with the synthetic biological intelligence, with the real living brain cells combined with artificial neural networks, they think there is possible. But it's not only going to be a physical problem, an engineering in terms of computing problem, and a biological problem. It's going to be also a philosophical problem, because in order to see whether if a machine is intelligent or not, we have the Turing test. But how do we see if a machine is conscious? Someone says a Turing test, which is more advanced. Other people say the mirror test. There is something similar at putting a machine also in a metaphoric way in front of a mirror and see how the recognitions would be. But it's almost impossible to determine that a machine can be conscious. So, because we could say why he's conscious, but before saying why he's conscious, we should determine the definition of consciousness. So, we have an emergent connection with synthetic minds, which, as I said, is an hybrid system of neural actions and computations. And this leaves pitch to an emergent connection, so to something which is going to be completely new thanks to this biological integration and hybrid architecture. Now, there is also going to be the ethical perspective, because as a scientist, we have also to think about ethics, since we are dealing with people that have emotions, just like each one of us that have a moral and that are going to shape ethics. So the questions which are going to be made from an ethical perspective to synthetic biological intelligence are: do biohybrid systems possess ethical status? And can learning system cross into sentences? So there is the potential of an emergent consciousness, which is going to be completely new, and scientists are thinking, does it have rights? Scientists are posing also ethical questions. So when it comes to that's what I want to say, and that's what I'll say. When it comes to a new form of intelligence, whether if it's artificial or synthetic, there are going to be involved everybody: philosopher, engineers, lawyers, people who comes from many sectors, biologists, neuroscientists, everybody, because intelligence is something which is going to be the first step of anything that we do. That is why there is going to be this ethics, this ethical side, and this ethical sphere. Now, another question, as I said, is should lab-grown neurons have data rights? Which is a crazy question. But it is a question which is not anymore something that is going to be representing science fiction, but there is going to be representing reality. Now, what is the future of intelligence? The future of intelligence is going to be the union between biology and hardware. So, in my personal view, as science continues to grow, the future of and the evolution of intelligence will not be just the biological intelligence. There is the natural evolution, as one of my colleagues said. Indeed, I really liked the first presentation because he was talking about the biological evolution of humankind and history. And he went to the present, and I am going to the future also with synthetic intelligence. There is going to be the future of not only artificial intelligence, but the future of intelligence. Because there won't just be human thinking, there won't just be human thinking with machines, but there will be a new form of intelligence. There is going to be a much more energy efficient one, and according to many scientists also, and perhaps conscious, synthetic biological intelligence, a new form of intelligence which will come from the union of us with machines. Anyway, I really enjoyed talking to you about this new form of intelligence and this new form of AI. And I'm willing to take any questions whatsoever, and let's stay in touch in order to keep studying and keep learning, because we are always learning and we are always studying, as you all know, and keep making networks to make the humanity progress, because we are all here as individual, and in conferences like this we are giving our contribution to share knowledge. That is one of the most precious thing in terms of studying. So thank you, and if anyone has any question, I am willing to answer. Thank you very much for listening.
Thank you, Doctor. A wonderful presentation. Congratulations, was a treat. Now tell me, myself, Dana, how can I use this? How can I learn? How can I use the AI learning for me?
All right. So how can you use the high learning for you? Basically, in this, thank you for saying that this was a wonderful presentation, really. And in your case, basically, in the future, this new form of synthetic biological intelligence will be very, very important because it will increase the applicability of AI. So you already nowadays can use AI with AI agents, which I personally know how to implement, and I help many people from various sectors, and I could help anyone who is willing to be helped with AI. But the main concept of synthetic biological intelligence is that it will be an AI, but more powerful. Why? Because, for instance, if you want to use for your personal life an AI to generate content, it will consume power, all right? So it will consume power, and you can generate a certain amount of content based on how much power it consumes, right? But in the future, with the synthetic biological intelligence, it will use less power, so you can generate more content. So in anything that you do with AI agents, with generating content, with the medical stuff, with having lectures with your digital clone, in anything that you do, this will be empowered because it will consume less energy, so you will just do more, and everybody would be able to do more in anything that we do by implementing artificial intelligence in our lives.
It is biological intelligence. Is it available right now?
Yes, there is the CL1, there is the first computer. There has been released by Cortical Labs on March. I don't remember exactly the day, but it was released on March. And with this computer, there is a less consuming in terms of power
How do you
of
call it?
processor.
Cortical? What's the
Cortical
name of it?
Labs. Cortical
Cortical.
Labs. If I have spelled correctly, it was Cortical Labs. And they have released the first biological computer. But what I'm trying to say is that, I mean, even if you don't buy the first biological computer, you can already use AI, as my colleagues said, with AI agents and much more. And this is good. And another thing, in the future, with this new form of intelligence and synthetic biological intelligence, everything that you will do now and that everybody does now with AI, it will be even better because there will be less energy to be consumed. So it will be much better and also more sustainable.
What I would like for this biological or artificial intelligence to help us be happy. Wouldn't that be
Yeah,
nice?
it
I
it
think
can be very, very nice. You know,
to
it can
find
be
a
very nice.
solution to give to get a program to give us boost of happiness.
It can
You
be
know
very
that
nice.
that is at the base of treating post-traumatic stress syndrome, which I've
Yeah.
seen children victims of violence in Africa. So that is my dream that one of you guys will put together a program in biological intelligence to give boost of happiness.
Look,
Thank you,
look.
Antonio.
It
Grazie.
it could be very nice, and you are welcome. You are more than welcome, and prego, as we say in Italian. And thanks everybody for listening to me. If there is anyone else who has some questions, I will be happy to
Io
answer.
parlo italiano perché ho abitato a Monaco.
Complimenti,
I have
bravo.
just one question for Antonio, if it's possible.
Yeah, please.
Okay, Antonio, thank you very much for your very interesting presentation, first of all.
Thank
And
you.
second, I would like to know, in your opinion, which is the suggestion that you give to a biological researcher that now is finishing a degree. So how can he is evolving this profession thanks to the AI opportunities?
Well, yeah. Thanks for your question. So it's not only for a biological person who has just come out from the college and who is going to make his career. So he is going to make network to work hard, but it's for everybody. So I strongly suggest to just about everybody from any kind of sector to implement AI skills and become an specialist of AI, which seems hard, but it's not actually that hard. You know, with months of hard work, I genuinely believe that everybody could become an expert in AI. And personally, getting back to your question, from a biologist, it is very important to be in touch with the people who are working in this field, in the field of CBA, of synthetic biological intelligence, because from a technical perspective, it is going to be the future. Why? It is going to be the future since countries and companies are interested, everybody in spending less, and everybody is interested not only in spending less, but also in implementing AI. So as we say, 2 plus 2 is equal to 4. Synthetic biological intelligence, it could be the future. And as a biologist, I would see myself as a pioneer of this, because when the market is not saturated, I could be extremely helpful to help countries and to help companies of any kind, like any countries with no limits, anyone who needs help, and also any company who needs help with no limits to implement this synthetic biological intelligence, which will make consume less. So if I was just come out from the college as a biologist, I would be in touch with the people who are working on this, and I would come up to them with the new ideas and trying to make them a good impressions, and trying to make as much network as I can, and start working for them in a good way. That's what I would do, because in the next decade, this is the future. As my professor in Lewis of AI said, AI is overestimated in the short term, but is underestimated in the future, because in the future, even the future of televisions, for me, it will be done with AI, thanks to the power of generative adversarial network. So it's something, that's what I would suggest to these biologists, to be in touch with people who are working on this, and to be a pioneer on this. So to become an AI specialist and biologist at the same time, young, who is willing to work, who has energy, and working on this. That's pretty much it. Then maybe from a money perspective, in the short term, he's not that much, but in the long term, it will be. Anyone can make his own choices, and I am passionate about both of the sides, about selling AI to professionals, to organizations, and also about dig into what the future of AI is going to be. And that's pretty much it. Thanks for your question.
Thank you for sharing your perspective, Antonio. Very interesting. Thank you.
You're welcome, and you are welcome, and prego.
Prego to you.
I have another question. You said something about television, the future of television, because adverse something?
Yeah, so generative adversarial networks, those are the neural networks which are able to generate content, right? So those neural networks can literally generate content because they have a generative artificial neural network that can generate content based on the real contents that we give them, and a discriminative neural network which will distinguish what is the content that was generated by AI and the real content. And those are algorithms which are going to generate content, video, images, and audio also. And soon there will be the first movie which is completely released by AI, with actors who have never really existed, and in the future with more powerful hardware such as the quantum computing or the biological computer, there could be entire TV series which are generated by AI in a few minutes. So it will be just about crazy in a positive way also, in terms of generating content. Also because if a television owner has to pay a good person with a good aspect to talk about the meteo, all right, is going to be a good thing, but what if an AI clone, which is completely generated by AI, can do that for that television owner? Is going to be costing less. So it's going to be that the choice. And that's why the future of television, in my view, is also with AI.
Do you think they already use AI to create content and fake videos and stuff?
Oh, yes, I do. 100%. Yeah, they. Why? Because it's like having the cars, all right, and asking a question like, do you think that they already use the cars to exceed the speed limit? Idealistically, it would be better if no one does it, but yes, they do. All right. So, and the main point is that only whoever has the code can literally prove that that content was generated by AI.
You
So,
have
yeah,
code you can prove by a code?
yeah.
Can you
Only
teach me how to prove that? Can you teach me?
for sure. Yeah.
Oh my
I
God, we're gonna
could
all
be
become
able.
your students. You're gonna teach us how to prove, how to detect the code of fake. That will really change the world of
I
news.
know. I
That's
know. I
fantastic.
know.
That's wonderful.
Thank you.
Antonio, I want to invite you. Uh, 12th of October is my birthday on the 13th, but on the 12th we have a meeting in New York. You have
All
time
right.
to prepare. Please come. Yes?
All right. I see what I can do. Thank you for the invitation. Thank
Grazie,
you very
Antonio.
much. Thank you very much. Prego, and thank you with all my heart to all of you. God bless you all.
Be very happy and see you tomorrow for the panel.
All right. Thank you. Thank you very much.
And now we have